Good evening, everyone. This talk is going to be in English. And I'm Gloria. I'm not a programmer. I am an environmental engineer by training, and now I work as data scientist for a consultancy company called Renby, which is mostly work with geographical data, geospatial data. And today, I would like to talk about how Python and satellite data can help us taking care of our health. And in the end, I will show you a practical example of this and Jupyter code in Python. Would you like going to the sea? You are enjoying the sun with your mojito, a cold bit better, right? And in the end of the day, you just took a sunburn. Have you ever experienced that? It's annoying, right? Have you ever wondered why this happened? When we took a sunburn, our skin gets red. And this is a response of the damage that the solar radiation makes to our cells. This energy corresponds to ultraviolet radiation is so high that can damage our DNA, and the cells who don't die can turn themselves into cancer. Just keep in mind, if you take more than 5 sunburns, you can multiply by 2 the possibility to get skin cancer. The other day I saw an interesting statistic about the world cancer research, and I saw that the country have the highest rate of skin cancer are those who are in average have the highest exposition of solar radiation. For example, these are the value of solar radiation at global level for February 4th. And that day, the Australian friends was exposed to solar radiation more than 16. Just keep in mind that with 11, you have to get the total protection. The solar radiation is not only linked to skin cancer, but also to skin aging. Just imagine that those who take more solar exposition are used to look from 8, 16 years younger. And now you know what you have to do between 20 years if you want to look younger, right? Wear sunscreen. But solar exposition is not the only factor connected to skin aging. There are a lot of other factors like stress, lack of sleep, and the quality of the air. There are a lot of pollutants that determine the quality of the air. And today I would like to talk to you about the most relevant one, particulate matter, NOx, and ozone. The particulate matter are really tiny particles. They are so tiny that can penetrate our skin and damage it. You can see here in comparison with the human hair and the sand. They are used to be present in nature, like for example the dust of the pollen. Here, this is an animation about the PM value of the September 27, sorry. You can see here the dust of the desert of Sahara, and can you see this? What could be this? We are in the end of September. There are PM in the middle of the ocean. What could be? No? Is that one? Is the Trami typhoon. This is the visualization of global level of PM particle, and you can see here the Trami typhoon that was in front of that day was in front of Taiwan, and it was pointing to Japan. And because it has an effect like a vacuum cleaner. What? You can hear me or not? No? Oh, sorry. I try to speak louder. And the other 2 pollutants are NOx and ozone. Have you ever seen in the city, if you see far away, the atmosphere colored like red, brown? This is a clear indicator of the presence of NOx because this pollutant has a red color. This is an indicator of the human activity because it's produced by combustion like cars, industries, skipping, and with the solar energy have an effect and produce at the ground level ozone. Ozone is a really friend of us because can protect ourselves from the UV, the solar radiation we saw before, but when it is a high altitude, sorry, like the ozonosphere. When it is at the ground, it's really dangerous for us because it has a really, it's really aggressive, so can irritate our skin. So, for example, if these one are the value at global level of NOx, and this is the solar radiation, we can see the production of ozone. So when there is ozone in the atmosphere, when there is NOx in the atmosphere like that, no? It turns itself with the presence of the solar radiation in ozone. Now, how can we get all this amazing data? Well, from satellites. There is the European Commission is sending in orbit a lot of satellites under the program Copernicus. These satellites are called the Sentinel, also called the watchers in the sky, because they are responsible of monitoring one exactly things. For example, the Sentinel-2 is responsible for the monitoring of the agriculture, the Sentinel-3 from the sea, and the ones who is responsible of the monitoring of the atmosphere monitoring is the Sentinel-5P, that one. So all the entire process work. Basically, the satellite gather the data and pass the data to that organization here. This organization make a simulation of the data and give the data back to us in a grid format every hour with 5 days of forecast. So the data are in a grid format, but which are these grid formats? These data are crazy data because they are 4 dimensions into one file. So basically we have longitude, latitude, altitude, and the time. And data from Copernicus has only 3 dimensions: latitude, longitude, and altitude. And pollution data are provided in the concentration, and radiation data are provided in biological effective dose. But which is this biological effective dose? The biological effective dose is the quantity of energy coming from the sun that reaches to us each second per square meter. So that means that we are considering the effect of deduction of the ozone, so of the ozonosphere. So it's linked with the UV index with this correlation here. So all the graphics we saw before was generated in Python, and there is the code available here in this repository. So you can just, there are also the data, so you just play with it. So the grid form, Python is really good to manage this kind of data. Also because, this data have a spherical format. So when you have an issue when you want to plot in 2D dimension. So Python also help us to make us fit of this data and visualize it correctly. And now we will see how to manage this data, also to make this animation of this. And now, do you remember when I talked about a practical example of this data, how this data can help us? I would like to show this application, which is that give to us data in real time about the quality of the air and the air pollution. So if we have time, I would like to see the code. You can see. Ah. Houston, we got a problem here. No. Why I cannot see it? Perfect. Okay, this is the code I use for reading the data in grid file and visualize it. I use pygrib, which is a module in Python created to manage this kind of data, matplotlib, and numpy. So here, just read the data in this folder. Okay, here, this is the structure of the folder, which is in GitHub, and you have here in this folder pollutant. So you have available the data of 2 days, the 19th of September and the 26th of September. They are here. And for example, this code is about the UV index, how to calculate the UV index. So I just read the folder and read the data, which is the grip file. I open it and apply the calculation to just derivate from the solar radiation to the UV index. And here, I use numpy because when Python reads this data, the grip file, Python reads this data like an array. So I can use numpy, and I use this to shift the code, to shift all the data to solve the problem of the visualization we saw before. And I plot the data in a base map using the cylindrical equidistant projection. So I plot this data in lat long into the map, and I define here all the CSS of the map, let's say that. So I draw the coastal line, the map boundary, meridians, parallels, and the color, and the color bar. And here we can see the visualization of the grip file. And to make the animation, I define a function to call it, I call it this function is here, animate. So basically I create a list reading all the file present in the directory, and I order it in, where is the code? This was like, okay. And I order in a numerical sort from the lowest to the biggest. And in the end, I just plot, okay, it's here. I plot for its grip file an image, and with this function, I can create a GIF and visualize it here. Okay, you also have the code if you want to play with this data. You also have all the prepared Jupyter notebook. For example, here you have the one for the creation of the GIF about the particular matter we saw before. So, okay, you just clone the GitHub repo and play with it. Give me some feedback how to improve my code, and I will enjoy it. Thank you.